welcome to your maths lesson for Thursday the 28th of January. Today we are going to be comparing area. So, for our warm-up today, I'd like you to choose your chosen multiplication method to solve these problems. Okay, so you can use grid method, which where you partition the numbers and times them and then add the numbers back together at the end, or you can use the expanded column method, or you can use the contracted column method. So whichever method you like, pause the video here and do those four sums, please. Okay, I will just change the slide so you can see what the answers are. I'm not going to go into a lot of detail to go through the answers for these, but those are the answers that you should have got using whichever chosen method you decided to use. So you can pause there for a second and have a look at your answers. If you've made any mistakes, then I would recommend that you maybe try one of the other methods, do the sum again with one of the other methods, and to just check where you've gone wrong. Okay, so let's move on to the main part of the lesson. So today we are comparing area, as I said earlier, and these aren't rectangles that we're going to be looking at today. So we're going to have to just go back to our trusty counting the squares. We can't use that method of multiplying one side of the shape by the other because they're not rectangles. So we have to order the shapes from smallest to largest. And remember, don't forget that the area is the space inside a shape. So, for example, if we're counting the area for this shape, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I understand, obviously, that you can't, at the moment, put little dots on each square as you're counting them because it's on a screen. But if you had a piece of paper in front of you, it's a really good idea to put a little mark on each one so that you know you've counted them. And what I would suggest is when you're counting them on the screen is that you count them in kind of like a pattern. So count this, all of this row, then count all of this row, then all of this row, and then all of this row, or that one, and like that. Do it in some kind of pattern so that you make sure you haven't missed any out. Okay, so here I counted that there were 14 squares. Each square, for the purposes of today, is going to be 1 centimetre squared. So there are 14 centimetre squares altogether on this one. So just pause and have a count of the others and then put them in order. So just the number, the letter of the shape. So we've got A, B and C. So put them, the letters, in order from smallest to largest area. Off you go. Okay, so we've already done this one together. We said that one was 14 centimetre squares. So now we're going to do B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one is 10 centimetres. It's not just 10 centimetres. 10 centimetres is a length, isn't it? It's 10 centimetres squared. So what I'm saying is that there are 10 squares, centimetre squares, in that shape. Okay, and then moving on to C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to write that as well. And hopefully, although you haven't got a piece of paper with the pictures on in front of you, it's a good idea to write just on a piece of paper in your maths book or whatever those areas down so you don't forget. And then we have to write them in order from smallest to largest. So the smallest number there at 14, 10 and 12 is 10. So B comes first. And then I do a little comma so that I can separate them out. And then the next smallest out of 14 and 12 is 12. So C comes next. And then the last one is obviously A. So you should have got B, C, A is the order, smallest to largest in area. Moving on. We're going to do the same thing again. So if you can pause the video here, and then you can have a go at this one. Okay, so off we go again with our counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one is 10 centimetres squared. Got to put that 2, just it's a bit smaller and written up, sort of goes up in the air like that. Then the next one, shape B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that one is 12 centimetres squared. And then shape C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that one is 11 centimetres squared. And then to put them in order from smallest to largest again. So A is first because 10 is the smallest number. Then I've got 11 and 12 left. So 11 is the next smallest number. And then 12 is, oh, where have they gone? They disappeared up there. And then 12 is the last one. So it should read, you should have A, C, B. Okay. Moving on. Compare the area of these shapes using the greater than, less than, or equals symbol. So once again, if you pause the video and see what you think, which symbol you think goes in there. You do need to probably write down what the area of each shape is, but the question isn't what is the area of each shape, it is which symbol do you need in there. Okay, so off you go. Okay, let's do this one together then. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That one is 9 centimetres squared. And then this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I want my I'm doing my symbol, and I'm going to do it round that way because this is the greater one, isn't it? It's the bigger area, has the greatest area, the biggest area. Moving on. This one has already been done, and we have to decide if it is true or false. So the greater than symbol is facing this way, isn't it? So it's suggesting that A has a larger area. Okay, so pause the video again, work out what the areas are, and then say if you think this is true or false. Does A have the greatest area? Okay, let's do it together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is 13 centimetres squared. And then let's have a look at this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ooh. (16 centimetres squared is going there. So now if I have a look at my original statement, this is saying that A is greater than B. The area of A is greater than the area of B. And the area of A is 13 and the area of B is 16. So I am going to say that this is false because actually B has a greater area, doesn't it? It's got an area of 16 centimetres squared there. Okay, let's move on. Here we are comparing our shapes again. It says which statement is incorrect? 1, A has an area smaller than B. 2, the area of A is 4 centimetres squared smaller than B. And 3, B has an area of 14 centimetres. So once again, 14 centimetres square. Once again, we're going to have to work out what the areas each of those shapes first, and then we can see which one of those statements is incorrect. So could you pause and do that for me now, please? We'll come back together again in a second. Okay, so let's do it together. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one has an area of 9, and I'm going to write that down rather than try and hold it in my head because I will forget otherwise. And then go to the area for this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the area of shape B is 13 centimetres squared. Okay, so now we've got to work out which of these statements are correct. So A has an area smaller than B. Well, I can see that A's area is 9 centimetres squared and B's area is 13 centimetres squared. So I think that is true. A does have a smaller area than B. So I'm going to give that one a wobbly tick. Next, the area of A is 4 centimetres smaller than B. So if I look at my area A, okay, it's 9 centimetres, and this is saying that that 9 is 4 centimetres less than 13. So if I put 9 in my head and count on 10, 11, 12, 13, then I can see, or I might just know off the top of my head, that 9 is 4 less than 13. So that one, once again, is correct, and I'll give that one a tick. And then the last one, now I'm expecting that this one might be wrong, because it says which statement is incorrect, which sort of suggests that one of them is, and I'm pretty sure those are right. But what I'm going to do is read it anyway and check, because if I think this one's right as well, then I'm going to have a look at those first two again, aren't I? So the statement says B has an area of 14 centimetres. Well, no, I've worked out that B has an area of 13 centimetres. So I don't think that that one is correct. So which statement is incorrect? And I'm going to highlight that one because I think that that one is incorrect. Okie doke, moving on. So this is your hinge question. This is a bit in class where you'd be sat with your whiteboard and you'd all be showing me your answers. Hopefully you will be very soon. So Kieran and Max are comparing the area of two shapes. Kieran says, shape A has a larger area. Max says, no, the shapes have the same area. Who is correct? Prove it. Okay, so the one thing I would say is that when you look at some shapes, sometimes you think you know which one has the bigger area. Sometimes it's really obvious. But in this kind of instance, it's actually quite tricky to tell because they're very different shapes. And from our lesson yesterday, we could see that when we organise the squares into different shapes, they can make the area look a lot more or a lot less than it is. So the first thing you need to do again is to work out what the area is of each of those shapes and then work out who is correct, okay? And the prove it bit is you're working out the area of each, okay? So say who's correct and prove to me who is correct. Off you go. Okay, let's do them together. And I know you can't draw them, so I'll do the dots on them for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that one has an area of 11 centimetres squared. Then I've got this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one has an area of 10. So Kieran said that shape A had a larger area. Well, I've worked out that shape A's got an area of 11 centimetres squared and B has got an area of 10 centimetres squared. So I think at the moment, I'm thinking Kira might be right Kieran, right. So I'm going to tick her there. And then Max is saying the shapes have the same area. I don't think that's right, because this one's got 10 centimetres squared and this one's got, sorry, this one's got 11 centimetres squared and this one has 10 centimetres squared. So for my answer, I would write something like, I think Kieran is correct because A has an area of 11 centimetres squared and shape B, B only has an area of 10 centimetres squared. Okay, so something like that would be your prove it. And actually your proving it is the sort of counting is up here when you've drawn it out and you've clearly counted and worked out what the area is. So let's move on to the silver activity for today. Now these are a little bit dinky. Just wondering if I can make them a little bit bigger for you, but obviously it says circle the shape with the largest area. So clearly you can't do that. So you're just going to write A or B. You absolutely don't need to be trying to screenshot things and print them out and stuff because it's just not necessary. Okay, we'll know what you mean. Okay, so write down whether A or B has the largest area. Okay, don't guess. Make sure you write on the shape or under it which one has what the area of each shape is. You can't write on it, can you, silly me, because you haven't got the sheet. You can write A equals whatever and B equals whatever and then circle the one that has the larger area. Okay, and then here there's some true or false ones, so you can just write if they're true or false, and then there's some comparing ones at the end, okay, to work out, just as we did before, which statement is incorrect. So you can pause here and have a go at that one. Okay, and we'll move on to gold now. So using the clues below, give the possible area of the shape, the area of shape B. So it gives you one shape, gives you some clues, and you have to work out what the area of shape B might be. Okay, it hasn't shown you the shape, it's just given you shape A, and it's going to tell you some things about it, about shape B, and then you want to try and guess which one it is, and the same here. Okay, so try and work out what the possible area is of those shapes. Okay, if you've restarted the video, then I'm thinking that you haven't had enough yet and you want to have another look at platinum, which is good. So let's move on to that one. So you've got to look at the shapes and you've got to spot the pattern and explain how the area is changing each time. And then draw the next shape. What is its area? Can you predict what the area of the sixth shape would be? Can you spot any patterns in your answers? And this is the kind of thing I can remember doing this sort of thing at secondary school. So it just goes to show you how much maths you're expected to do now that you're in year 4 and you're doing things that maybe children used to do years ago in year 6 and year 7 maybe. So it's quite a tricky thing to do, but it's actually can be quite fun as well, because the fact that I remember it must mean that it was quite fun to do. So have a go at that one, and then when you've done that, you can share with us on Dojo what you find out, and we will look forward to seeing that. And then I will see the rest of you tomorrow, and it's Friday tomorrow, so it's nearly the weekend. Okay, bye-bye.